those of you who weren't here, this was our bellwork problem. You might want to pause it if you want to look at it. This is problem number 18. We found the area of each of the sides and add them together. That was problem number 22. And that was problem number 8, I believe. Guys, I have an octagonal prism and a cylinder right here. Which one would hold more water? Octagonal prism, cylinder. Okay, Chris. Chris thinks it's the cylinder. Why, Chris? What do you mean the same size? Like this? What do you mean it's the same size? You're right, but what is the same size? Okay, so what do we call the distance around this? Circumference. Okay, well, we could, actually, that's better. The diameter of this is the same as the distance across this one, is what you were saying? Okay. But what if they're different heights? Well, they're actually about the same height. What do you think, Isaac? The octagonal prism kind of cuts corners. How many of you guys, let's vote on this. How many of you think the octagonal prism holds more? How many of you think the cylinder holds more? How many of you didn't raise your hand and don't care? All right. Okay, so we found out the octagonal, or the cylinder, because it had the same height as the octagonal prism and the same diameter. Because the octagonal prism cut corners, the cylinder held a little bit more water. Okay, you guys, today our objective is to find the volume of cylinders and prisms. Okay? We're going to learn how to find the volume of cylinders and prisms. Actually, volume of cylinders and prisms is a little bit easier than finding surface area, because usually the formulas are quite simple. Okay? There's the formula for finding the volume of a prism. It is volume equals big B times H. What do we mean by big B again? Remember we talked about this last time? What does big B stand for? It doesn't stand for, because little b stands for base. Little b stands for length of base. What does big B stand for? Area of the base, that's right. Okay, big B stands for area of the base. Wouldn't it make sense, if you guys think about this, if I take this prism right here, and I was to fill it up with centimeter cubes, I would, first of all, fill up the bottom with one row, right? Matt, and you guys, can you please listen? I would fill up the bottom with centimeter cubes, one bottom, or the whole bottom of it, right? And I would find out the area of that bottom, and I would times it by how many stacks, how many levels I'd have to put on there to bring it all the way up there, wouldn't I? Yeah, really. Yeah, that's all you have to do is you have to do the length and the width, huh? Wouldn't you? And that would help you find the base, the area of the base, and then you times it by, you can then stack one up the corner right here to figure out how tall it is, right? Okay, good. So that's how you find the area of a prism. Let me show you also a cylinder, and then we'll do a couple example problems. Cylinder volume formula. Cylinder volume formula. That one is volume equals pi r squared times height. Did you know that's the same thing as the area of the base times the height? Because what does pi r squared stand for? No, pi r squared is the area formula for what? A circle. And that's going to give you the area of the base, isn't the base of a cylinder a circle? So if you look at that, so you find the area of the base, and you times it by how tall it is. Okay? So these are, these, you guys, cylinders, very applicable. There's a lot of things that we fill up with cylinders, don't we? Cans, water tanks. A lot of shapes are cylinders, and we fill them up with things. So very applicable, something that we can use. Okay, so that's that formula. We're going to do a couple of problems here. We're going to start with this one right here. Let's say that I have a triangular prism. Let's say that that's a right angle right there. That's 4 feet and 4 feet. And I go down. Okay. And let's say it's a right rectangular prism. And let's say the height of this is 20 feet. That's 4 feet, 4 feet, right? Do I have enough information to find the volume of that? Okay, according to the formula, what am I going to find first? The area of the base. What shape is the base? Okay, so everybody find the area of the base. Go ahead. I'm going to give you 15 seconds. Okay, how many of you got 8? Okay. Okay, since it's a triangle, the area formula for a triangle is area equals base times height divided by 2. We know that the base and height are 4 and 4, right? So 4 times 4 is 16. And 16 divided by 2 is 8. That's the area of the base. Then what do I do with that? Yeah, because my volume formula is area of the base, which is 8, times the height, which is 20. And I get 160, right? 160 what? Feet cubed. Why cubed? Yeah, they're cubic meters. We're filling them up with cubes. How many cubes would fit in there? And so it's a cubic square feet. Okay? Does that make sense to you guys when you see something like that? All you have to do is find the area of the base times it by the height. It's really simple. Let's do another one. Let's do an octagonal or a pentagonal prism. Let's do something like this. Let's say I'm not very good at drawing octagons, so you know what? I think I got this thing on here that can draw my octagon for me. Or my pentagon. I'm going to do this. And we are going to go that one's supposed to be dotted back here. What do dotted lines represent, you guys? Yeah, okay. So let's say this one, let's say that that's a, what do we call the distance from the center of that pentagon to the side? Do you remember? It's kind of like a radius, but we don't call it the radius. What's the other word we use for it? Yeah, apothem. I call it apothem. I think I've seen it in books called apothem. Okay, I just in the habit of saying it that way. Let's say that's this right here. Let's say that that distance right there is 2.75 centimeters. Let's say this is 4 centimeters, and let's say this is 9 centimeters. Do we have enough information to find the volume of this? Okay, we got to find the area of what first? The base. What shape is the base? It's a pentagonal. It's a pentagon, and so this is a pentagonal prism. So how do you find the area of the base? Or the area of a polygon, of a pentagon? Area equals, say that again, 1/2 times the apothem times the perimeter, capital P. What's the perimeter of this thing? No, not 25. 20. Why 20? How many sides on the polygon? 5, and they're each 4. 5 times 4 is 20. What's the apothem? 4 times 5 is 20. So that's going to be the area of my base. Someone calculate that for us. Is that the right answer? I went 1/2 of 20 is 10, and 10 times 2.75 is, I'm going to move the decimal one place to the right, right? 27.5 square centimeters. So now I got to find my volume. How do I find my volume? How am I going to find the volume, you guys? Base times height. What's the base? 27.5 times what? Times 9. What is that going to give me? Someone do that in your calculator. 247 point what? 0.5 what? Centimeters cubed. And that's how we find the volume of that. Any questions? So you guys remember how to find the area? Write down this area formula for polygons, you guys, in case you don't have it. That works for any, like a hexagonal, regular hexagonal, regular pentagonal, regular octagonal. Okay? So all you have to do is find the perimeter, times it by the apothem, divided by 2. Okay? You're going to need that one today. Okay, let's do a cylinder. All right, let's say we have a cylinder right here. What information do I need to have to find the area of or to find the volume? Okay, listen to this, Matt, Mitchell, guys. What information do I need in order to find the volume of this? What? Okay, what do we need to do to find the volume of this thing? Well, I need to know, find the area of the base. So what information do I need to find the area of the base? Radius. That's all I need is a radius, isn't it? Let's make up a number. What do you guys want to say the radius is? We'll say 11 feet. How's that? Okay. What else do we need to find the volume of this? The height. What do you guys want to say the height is? Well, if you compare it to that, maybe about 30, right? Because it was not quite 3 of those. And 33 would be 3 of those, right? So I got to find the area of the base. What shape is the base? Circle. So we remember the volume formula? It's pi r squared, which is the area formula for a circle, times the height, right? So area is pi r squared. So that's equal to pi times 11 times 11 squared times, well, we just need the area right now, right? Pi times 11 squared. That's going to be 121 pi. We'll so that's the area. So now the volume is going to be 121 pi times the height, which is 30. Everybody put that in your calculator. 121 times pi times 30. Say that again. Really? $403 what? 11,403 feet cubed. Don't forget the cubic feet. How many of you think you can do this? Why not? You need some help with it, Jordan? Okay. That is how you do it. Okay, here is your assignment. Actually, I don't know why you know what? I had all these problems already made right over here. Look at all those. I had them all done for you. There's your assignment, guys, right there. 14 through 24, all. Page 514, lesson 12-3. I'm turning it off.